As 5G networks support 1,000 times the capacity for billions of devices by 2025, new radio access technologies and existing wireless technologies will have to merge. So what breakthroughs in wireless network innovation can we expect that to realize for a network capable of providing zero-distance connectivity between people and connected devices? This 5G panel, hosted by TI Now and brought to you by Huawei, welcomes Peter Jarek. He's Vice President of Consumer and Infrastructure Services at Current Analysis. Next to him is Manish Singh. He's Vice President of Product Management, SDN NFV at Tech Mahindra. And on the end is Roger Ettner. He's founder of Recon Analytics. And gentlemen, welcome all of you to this discussion on 5G. Peter, I want to start with you. There's a number of analyst firms that say that 5G is really the next frontier for innovation for the entire mobile industry. Would you agree with that?
Completely. I mean, I think it's obviously where the industry is focused, and we recognize LTE has a long life. No one's going to argue with that, right? But I think going forward, particularly as we think of new innovations, the way 5G is embracing not just the telecom industry, but new industries, vertical industries, trying to pull those folks in to really create something new. Let's forget about the capacity, let's forget about the use cases, just to the extent that it's pulling in new participants, that those use cases support. Completely agree that really that's where the industry is looking for a good reason, right?
Yeah, I'd agree with that. I think clearly 4G is here, and it's here, it's getting deployed, and it's getting adopted, and I think that's going to continue for a foreseeable time. But I think from a frontier perspective, I think it's time for 5G to really start looking, bringing in new technologies, bringing in new solutions to really address the problems that are here and now, and also really enable the industry, the service providers, and the ecosystem to seize the opportunities that are here and now. And as Peter rightly said, I mean, from enterprises to the IoT is already making its moves and more. So the opportunities are here. We now need to start really coming together with new technologies and solutions that will meaningfully address the challenges and enable us get to these opportunities.
One of the key events are always these generational shifts. It's a complete reset of the competitive mix. So every time we have a new generation, we saw it from 1G to 2G, from 2G to 3G, and 3G to 4G, and we will see it again with 5G, is that the competitive situation resets and you start anew. So the carriers that have succeeded with 3G to 3G to 4G might not be the same winners with 5G. So that's why we see such a rush by everybody to really deploy 5G, because we saw in 3G and especially 4G that those who really pushed very aggressively ahead had a sustainable head start. And so this makes it very critical for everybody to really be at the starting blocks and get running as quickly as possible.
Manish, I want to ask you a question about how NFV SDN plays a role in 5G. How much flexibility do we need in the network for, let's say, 5G and LTE technologies to work in tandem? And how does SDN NFV play a role in that?
I think it's going to play a very critical role. And I see that as a foundation building block towards 5G. I think a couple of key aspects. So one is from a RAN perspective. I think we are going to see the deconstruct of the baseband unit and the remote radio heads and getting more towards a CRAN kind of architectures, really leveraging COTS platform. I think the key opportunity that I see is already addressed is how do we do compute workloads and data plane workloads on those platforms. I think it'll be an interesting question for 5G to tackle as we look at the frontier. How do we do meaningful signal processing in these commodity platforms and get those signal processing workloads on these. So that's one. The other thing, from a SDN perspective, I think SDN already is bringing some very key capabilities from a programmability perspective. And I think when I look at 5G, network slicing becomes very important to create horses for courses, creating networks that really meet the key requirements for certain use cases. And I think SDN becomes very critical to really deliver on that promise of those varying use cases.
I absolutely agree. What has been the developments that we have done now in NFV, SDN, has become really the foundation and table stakes as we go into 5G. Where we still have to do work is around standardizing this. Because right now, too many cooks are trying to create their own little soup, and we're losing economies of scale. So one of the things we have to do when we go towards SDN, when we go towards NFV, is really standardizing all of these processes so that we can have massive economies of scale on a global basis.
Yeah, I think if we go back to what Roger said earlier in terms of the need and the interest of folks to move fairly quick, I think let's be very clear. In terms of 5G, if we're talking about in the radio access network, we really don't know what 5G NR is going to look like, right? We don't know what the 5G air interface is going to look like. Yes, we've had vendors who've announced 5G NR capable or ready radios here this week at the show, but we're still kind of waiting on what the RAN is going to look like. That means that for folks that want to move early, they've got to start thinking about the core, right? So this fact that we know a 5G core is going to be based on a foundation of SDN, a foundation of NFV, SDN supporting network slicing. Yes, to Roger's point, we still need to figure out some things, let's say around management, around mono, about, for example, how do we sort of implement some of these. But the rest is standardized, right? We've got folks that are moving on VNFs, they're deploying VNFs, that's getting out there, they're moving from POCs to commercial. And that's more than just sort of a nice thing to do. They need to move in that direction so that they do have that head start on 5G. And it's a great thing that they can do that while they're waiting for the RAN to sort of get figured out.
So this discussion is really based on Huawei's most recent release of their 5G white paper. In the white paper, and Roger, I'll start with you if you don't mind. In their white paper, they state 3 major design objectives for 5G. The first one is implementation of massive capacity and massive connectivity. Can you sort of walk us through the significance of that?
Well, we will have significantly more devices on networks, using also up a lot more capacity. And you really need to significantly alter the approach compared to 4G to actually serve that. Because more and more people will use video on more and more devices, eating up massive amounts of data. And that definitely takes a different approach.
Manish, the second objective Huawei stated in the 5G white paper was support for an increasingly diverse set of services, applications, and users, all with an extremely diverging requirement.
And I completely agree with that. What we are already seeing, I think, with IoT, and I think this is going to only grow, is a very diverse set of use cases that the network will have to address. Because when you talk about things, different things have different requirements. On one hand, you talk about a smart meter, which you probably want to send a small amount of data. On the other hand, we're talking about a connected car, which might require huge amounts of video downloads. But more importantly, in case of a connected car, what about a driverless car, which might have a very critical latency requirement that when it is trying to get certain set of information from the network. So if you think of the network, on one hand, you have devices which have very low requirements, latency insensitive. On the other hand, you have highly latency sensitive requirements. And in certain cases, mission critical, life and death at stake. So I think all these things, when you bring them together and you say the network has to cater to each of these, that's what 5G needs to really address, really solve. And things like network slicing, we'll talk a little bit about on the radio, what all things need to happen from a new radio NR perspective. These are the solutions that we need to bring together in 5G to address these use cases and seize the opportunity that's right in front of us.
Peter, the third objective in Huawei's 5G white paper for 5G is flexible and efficient use of all available non-contiguous spectrum for widely different network deployment scenarios. What do you take from that?
Yeah, I mean, I think that we know, and there's no carrier that would deny this, that spectrum is, the most precious resource that we have in terms of making these services work. The difficulty is that, over time, you end up with situations where you don't have, as much as you might like it, big blocks of greenfield spectrum that folks can move into. So it's simply a requirement that as you look for new spectrum, you have to find dribs and drabs wherever you can get them and find ways to leverage them all. Problem is, some of those may be high band, some of those may be low band, some of those may be TDD, some of those may be FDD, some may be licensed or unlicensed or shared. And so you have to have a framework that allows you to leverage all of those different bands, all those resources you can, but that requires flexibility because each of those bands will have different requirements, right? Whether it's a licensing regime or propagation or whatever. So completely, particularly as we're looking to hit the capacity requirements that Roger talked about, as we talk about looking to figure out how we match those spectrums to the different use cases Manish talked about, really that spectrum underpins almost all of it.
I mentioned again at the top of the program, there are several breakthroughs in really fundamental RAN technologies that to really realize 5G network solutions. Huawei's 5G white paper mentions about 8 of them. We're going to touch on a few of them here. We can't touch on all of them. Peter, I'm going to start with you again, if you don't mind. One of those breakthroughs in RAN technologies to realize these 5G solutions is mass scale MIMO.
Sure. So I think that, just taking a step back, right? If we were doing just what we've been doing with LTE in new bands, it'd be nice, but it wouldn't be that much of an innovation, right? So these RAN innovations are critical in order to figure out really how do we squeeze more capacity out of the spectrum, and how do we make the most of it? Mass MIMO is interesting. It's something that we've been talking about for years and years and years. The difficulty of looking at massive MIMO is really, to some extent, one of physics, right? Because as you look at lower frequency spectrum, the idea of using 64 antennas in an array, at lower bands becomes fairly impossible because you're talking about antenna arrays that would just be huge, right? So where you would site those are unclear. When we move to millimeter wave spectrum, when we move to 28 to 39, to whatever it is, physics dictates that the antenna size can shrink. So we can get to a situation where you have a 64 element antenna array, which really opens up some new opportunities, right? Allows for beam steering, beam shaping, allows for directing the energy to the users, which one, makes that spectrum usable, but then 2, allows you to do things with capacity and coverage that maybe you hadn't before. Now again, maybe that's not possible in lower band spectrum, but it really speaks to the issue of how do we handle and how do we address all the different spectrum requirements. So massive MIMO is really one of the things that's going to make 5G work and allow 5G to leverage those higher band spectrum opportunities.
Manish, another breakthrough stated in the white paper for RAN technologies were single frequency, full duplex radio technologies.
Right, and I think just before I get to that, I just want to pick up on what Peter just said. I think from a spectrum perspective, if you look at, there is need for, in the context of 5G, it'll need access to lower spectrum bands for deep coverage, especially when you're talking about IoT and you're talking about battery life and things like that. There'll be need for that. There's also going to be need for to access the higher frequency bands that Peter talked about. In particular scenarios where you need to have spot capacity, hotspots, high data throughputs, low latency requirements, and I completely agree. I think mobilizing some of these higher frequency bands is the need of our, and a very, very critical need that 5G needs to address.
Finally, breakthrough in RAN technologies that will be realized over the next decade, let's say, 5G devices.
Well, a network is only as good as the devices that are on. It's a critical handshake. And so we will need devices that are much more flexible, smaller, more compact, better battery life. With it comes also that we need more and more radios in it because we have all these disparate frequency bands that need to be aggregated. And bringing that all together is going to really, to a certain extent, you're squaring a circle, but engineers have been fantastic and have been able to do true miracles what we thought were not possible. And I think with 5G we will have the same.
Manish, I want to go back a little bit, and this was mentioned by Peter earlier, about spectrum and how important that is really for deep coverage for 5G networks, not only for deep coverage, for other types of coverage as well. You touched a little bit earlier on SDN, NFV, and how that plays a role, but can you talk a little bit more about network slicing?
Well, so network slicing, I think, is one of the most key requirements that I see that 5G really needs to address. And You touched earlier at the start of the session where you talked about the three different use cases. And I mean, if we really take a very broad stab, you have enhanced mobile broadband, which is really taking mobile broadband that we know today in 4G and really enhance for even much better user experience. Then you have massive IoT, higher numbers of connectivity, deep coverage, low battery life, etc. And then we have this third key use case that comes up, which is around ultra reliability, mission critical applications, mobile health, driverless car, and more, right? How do we really enable industrial application? How do we enable these kinds of applications, which are latency sensitive, but also require very high levels of reliability? And this is where truly the 5G needs to address on both sides. One is on the spectrum side. What spectrum assets need to be leveraged for what use cases and when, so have a dynamic environment around that. But then on the core infrastructure side, equally having the programmability on the infrastructure, which SDN really brings, enables you to slice the network, create horses for courses, create solutions that cater to all these three different use cases. I think that becomes absolutely essential, critical that 5G addresses this.
And that's the key. I think part of going back to what's implicit, what Manish is saying is, think about it. In the move from 1G to 2G, 2G to 3G, 3G to 4G, we've generally been moving along one axis, right? More data or more voice early on, right? But one axis, right? And doesn't mean it was easy, but it's easier to solve one problem than to solve three problems, right? The issue with 5G is we've got these three main use cases. It's sort of more of everything, right? It's yes, more capacity, but more devices. It's different use cases. It's low latency, but also high latency. And how do you do all of these at the same time? And how do you do all at the same time economically, right? Without building one network that's completely over-engineered that no one could afford. And the question is, you need to be able to stitch the resources together for every single use case so that you aren't over-provisioning, right? When we talk about infinite bandwidth, which you oftentimes hear 5G referred to, it's the perception of infinite bandwidth. It's how do we deliver the exact right set of resources for any given use case, and just the exact set of resources, not too much, not too little. And the only way you can do that is by stitching together the right capabilities, and that stitching function is really what network slicing is about.
And network slicing is really about creating a custom network for just a specific usage application for the right point in time, for the right duration. So it makes it really very customizable, very flexible of what you can do with the network. And that's really a breakthrough innovation that we need for 5G.
I want to ask all three of you about really the applications we might see over the next several years that are supported by 5G technologies. Really want to talk specifically about latency sensitive applications or solutions. Really the answer we typically get is the connected vehicle is very latency sensitive for obvious reasons, but are there other verticals, and Manish, if you don't mind, I'll start with you, other verticals out there that have latency sensitive applications as well?
Absolutely. And reason we hear connected driverless vehicle is just because that's probably the most extreme use case of that. But to your question, industrial applications, public safety, mission critical in managing and controlling mission critical infrastructure. I think these are all applications. If you take, for example, the case of mobile health in itself, right? There are very specific use cases and applications that will require very low latency, ultra high reliability, mission critical networking infrastructure support for these mission critical applications.
Yeah, completely. I think whether it's industrial, we recognize if we're talking about remote control or control at a distance of machinery, right? There's latency involved in there that you need to be able to control, right? Going back to, I'm not too optimistic that we'll be seeing lots of public safety on 5G anytime soon. Public safety tends to want something that is a little bit more baked, so I think we'll see a lot of public safety LTE in the near term. But if we eventually want to move that over to 5G, and we will, well then yes, for those sorts of critical communications, public safety is almost the definition.
Well, for me, the killer app is really augmented and virtual reality. Virtual reality in a protected space because you're so immersed. But when that dictate you stay in one place. But when we look at augmented reality, and Google Glass and Pokemon Go are just the early examples, will really revolutionize it. because in real time you will get an overlay of all the data and all the intelligence behind what you see with your normal eyes, and just enhanced with so much more. When you go down the street, theoretically you could get the name of every person overlaid of that person, but which is a little bit scary. But you can have your own the Yelp reviews or a city guide right there with you all the time, and so any town will be your hometown because all the data is there at your disposal.
Now, the general theme for Huawei's 5G white paper was zero distance connectivity. And Roger, I'll start with you on this one. What do you think the message was there?
Well, the message there is that distance really doesn't matter, and that it works anywhere, anytime, any place, and even more so than what we've seen before. It's really the death of distance.
I think so to me, it's the very definition is, again, remote control, different kinds of devices, different kinds of applications. When I think about it, from smart cities to smart home to smart industries, there's a whole range of use cases that you can then start to draw up, right? Whether you're looking at home monitoring, or in case of smart cities, you're looking at managing and operating critical infrastructure, or in case of smart industries, you're talking about industrial processes and higher levels of industrial automation. All of these, again, will require that remote operations and are going to greatly benefit from that. And that's what I take away from that.
Yeah, I'll take it back to sort of where we started, right? This idea of is this the next frontier of innovation, right? And coming back to the idea that this is the next frontier of innovation because it opens up these opportunities, right? It opens up these ideas that whether it's because of low latency, whether it's because of the capacity, that we can set up these connections where, to Roger's point, the distance really goes away, right? Where we can have the remote control of distance, where it doesn't really matter because latency is sort of removed, right? Where we can be looking at having people who are remote coming together in what really seems like collaboration, not the way we have it today, right? Not with sort of a clunky, unified comm solution where it's pretty clear that we're all separate and we're talking over each other, but where we really do feel like we are in the same room, where we do have that zero distance.
I think it was an informative discussion as far as really what zero distance connectivity means and how that ties back to 5G technologies. So Roger, thanks for your time and being here. Manish, as always, thank you. Peter, thanks for being with us. And for our audience, for this on-demand version of this Huawei-sponsored panel, you can go to tinow.org. So long.